Once logged into the Windows Azure Management Portal, I select Mobile Services and create a new service. I specify to use an existing database, one that I've already created. You might choose to create a free 20 megabyte SQL database to go with your free mobile service. In this case, I deploy to the North Europe Data Centre, which is in Dublin, Ireland. I'm asked for credentials for my existing database. If you've chosen to create a free database, you'll need to create new credentials at this stage. It takes a few seconds for the service to be created. The magic of video editing speeds up the process for me. Once created, I can inspect the dashboard. The Scale tab shows me how many servers are assigned to this mobile service. In the free tier, I only get 1 unit, but as I change to the standard paid tier, I can scale up to 6 units that are shared with other customers. But if I need complete isolation, I can move up to the premium tier, which gives me dedicated units running only my code, and I can push the count up to 10 units. In this case, I leave auto scale off, but I get the option to scale out and back in response to counters like CPU and memory utilization. I can also specify the database size. Looking at the Data tab, you can see I have no tables created at this stage. That will change in a few minutes when I get to that part. Back on the Quick Start pane, I can get started quickly. I get the option of a Windows Store, Windows Phone, iOS, Android, or HTML JavaScript service. This is an Android video, so I'll pick Android. There are 3 steps. First, I'll download the Android Development Tools, or ADT. I'm agreeing to the terms and conditions and downloading the 64-bit version because this is a 64-bit machine. You can see I've already gone through the process of downloading the tools and have them already saved on my hard drive. They're 470 megabytes, so this optimization saves just a little bit of time for the video. It's a zip file, so I'll navigate to it and unpack it. Again, the magic of video editing is evident here. You can see the original zip file and the newly created tools directory. There are a few additional jobs to do. Load the Java SE development kit. I have it in my favorites, but if you go to http://aka.ms/Java SE Kit 7, JAVA SE KIT 7, Java SE Kit 7, you'll be taken to the site. Depending on when you're viewing this video, you might also want to explore the site for the latest version of the kit. At the time of video creation, this is the latest version. I agree to the license terms and pick a 64-bit version because my machine is 64-bit. I click Run to install it straight onto my system. And I have no idea why the final dialog ends up in the top left corner. I'm not quite finished. I need to modify the path environment variable with the Java details. So I drill into the JDK's bin directory and copy the path into the paste buffer. Then I get to the path variable, add a semicolon onto the end, and then paste the contents of the paste buffer in there. Then I go back and this time get to the path of the JRE directory and copy that into the paste buffer. I add another semicolon onto the end of the path variable and then paste in the JRE path. I'll just check it's all there properly. I can see I've got the path for the JRE, then a semicolon, and then the path for the bin directory, all the way up to the next semicolon. Back in the Mobile Services dashboard, I've done step 1. Step 2 is to create a table in a database in the cloud. It creates a to-do item table for the sample app that I'll download soon. The Data tab in the portal shows the to-do item table, but of course at the moment it's empty. There are no records. So now I've done step 1, installed the tools. I've done step 2, created the table. Step 3 is to download the sample Android app. This will be in a file called plankydroid.zip, which I save into my Android folder. It contains a top-level folder, so I'll extract the entire contents directly into my Android folder. I just want to show you a couple of things in this Android project before I open it up in the Android DevTools. I'm opening the Android manifest file and I can see the target SDK version is 17. Also, in the project properties file, I can see it's targeting Android 17. That means this project was built to target that particular API level. This particular app was built using SDK 4.2 and API level 17. The two go together. It means I need to make sure the Android development tools have the support for that version configured. By default, the latest kit has support for API level 18, so I'll have a little work to do in a moment when I fire up the Android tools. By the time you get to this video, the tools might be even further along. I usually prefer to drill into the Eclipse folder within the ADT bundle and pin the Eclipse tool to the taskbar. I click it to open it. I'm not going to use the default workspace. I'm trying to keep everything together in my Android folder. Okay, so the tool opens up. I can close down the intro page and then I get a clear view of the Package Explorer. That's a little bit like the Solution Explorer in Visual Studio. However, before I import the package, I need to set the tools up to support API level 17. I go to Window, Android SDK Manager. In this dialog, I look for anything labeled 17 and specify I want to install it, and then click to install the packages. I accept the license and sit back patiently and wait. Now this takes about 10 minutes, but with the benefits of video editing, it's just a few seconds. The next job is to set up the phone emulator. I go to Window, Android Virtual Device Manager. You can see one that I had in a previous configuration here. When you come to this dialog, it will be blank. I'm just going to delete it to get it out of the way. Because Android supports so many different phone versions, you have to build a virtual device that conforms to the target device or devices you're writing your app for. I click New, but I'll just go for the simplest option here, just for demo purposes. I just give it a name, Planky Phone in this case. I'll just pick the first device in the list, a Nexus 4, and this is the point where you might come across a box with insufficient options. In order to see API level 17 in the list, you need to exit and restart the ADT to get it to populate after having fiddled around with the Android Virtual Device Manager. So, I cancel out of this dialog, exit the ADT and restart. I retrace my steps, and this time, when I get to the target drop-down, I can see API level 17 is supported. By default, the tool suggests 1907 megabytes of RAM. However, there's an easy to miss little message at the bottom of the screen here that advises less than 768 megabytes of RAM on a Windows machine. So, from experience, I know that 756 megabytes gives me almost no problems. I've run this on 8GB, 16GB, and this laptop, a 32GB machine, and 756 megabytes always works on all of them. I can see the device, Planky Phone, in the list now. I'll now import the package, specifying I will import existing Android code. I navigate to the place I saved the package from Azure Mobile Services. I can drill down to the Android manifest, and the UI shows a nicely formatted version of what I saw before. This project is targeting version 17. I can also see it in the project properties file, but of course now in the SDK manager I added support for level 17. Now that I've added the virtual phone device, in order to get it to show up in the rest of the UI, I need to exit the tools and fire them back up again. In the Run menu, I select Run Configurations. I browse to the project, and then on the Target tab I can see the device. Notice the UI is a little bit confusing here. Ticking the device doesn't select it, highlighting it does. I can now hit Start. In the launch options, I usually say to wipe user data and hit Launch, and the virtual device fires up. Back in the Run Configurations dialog, I hit the Run button. This is where you need some patience. I use video editing to speed things along. The Android screen appears first, and eventually the sample app I downloaded from the Mobile Services site appears. It already has data such as the application key and the URL of the mobile service embedded into it, so I should be able to just use it straight away. So, first off, I'll go to the database and have a look in the To-Do Items table. Of course, there are no records because the app hasn't been used yet. If I add an item into the app running on the emulator and click Add, it makes a call to the Azure Mobile Services REST API and sends that data. It also reads it back out of the database using the same REST API once it's been successfully written. Back in the Mobile Services console, if I refresh the database, I can see the record is successfully stored. I can go back to the app and add another to-do item, then click Add. It must have completed the trip all the way to the database because you can see the app has read the data back. But let me just check to make sure. I refresh the database in the console, and there's the data. Now that I have the app running, I'll take a brief look inside it. At the back end of the mobile service is a database which has tables. This data is exposed to the service itself. There are 4 operations I can perform: create, read, update, and delete. As the data flows through these operations, I can insert my own Node.js scripts to modify the way the data flows. For example, when creating an entry in the to-do items table, I could check the length of the string and return a friendly error message if it's too long. Right at the very front end of this service is a REST interface. In the Android application, there is a mobile services client library that allows me to call simple methods, and it produces the relevant REST calls to make it to the REST API. When calling create, my own script can modify the way that create works. As I said earlier, maybe I'd check the string length and respond with a user-friendly error message if it's too long. It's the same when calling read, update, or delete as well. My own code can modify the way these operations are performed. I'm going to have a quick look inside the code now. In the lib folder, I can see the jars that make up the mobile services client I talked about. If I expand todoactivity.java, I can see right at the top here in the constructor for the mobile services client the URL of the mobile service. You might recall plankydroid.azure-mobile.net is the name I gave it when I created the service. So, when this application package was created, that configuration was built into it. It's the same with this extra piece of data here, the application key. Any mobile app that wants to call this service has to have knowledge of this key. I can see these pieces of information in the Windows Azure portal. Here in the Mobile Services dashboard is the URL, https://plankydroid.azuremobile.net, and I can also see the key here. A little look further down shows how to instantiate a mobile services table to point to the to-do items table up in the mobile services database. I can see the add item method, which inserts the text from the UI into the table. This ultimately results in a call to create in the REST API sat on the mobile service. The check item method performs an update. The refresh items from table method performs a read. Notice also that the services are handled asynchronously and they expect a callback to be passed in to handle whatever should be completed when the server request is finished. Back at the portal, when I drill into the Data tab, I can see the scripts from those create, read, update, and delete operations. The parameters passed in are the item itself, the user, and the request. I can see here the request is simply executed, but I can modify this script. In this case, if the length of the item is greater than 10 characters, then the response I send is shown here. Once I've saved it, I need to make sure the Android app is updated to take care of this new capability. I just modified the parameters in Create and Show dialog. I now go through the process of relaunching the app, only this time I type a long message into it. As expected, the error text appears in the app. The service itself will work with any code that can call the REST API, whether that's an Android, iOS, Windows 8, Windows Phone, or HTML JavaScript app. There's no need to do any service management on this infrastructure. It can be auto-scaled based on how busy the service is, and although there isn't time to show it in this simple video, the services can be extended to support app login with popular providers like Twitter, Facebook, Google, and Microsoft accounts. It also supports push notifications from Microsoft, Google, and Apple. The create, read, update and delete APIs can be modified on the cloud backend by you, the developer. For example, a simple modification might be to also store the date and time of the data update. You can create your own APIs, and you can also schedule jobs that you'd like to run on a regular basis. Incorporating this code into your own Android apps is a simple matter. Azure Mobile Services have a free tier. You can have up to a 20 megabyte database, can download up to 165 megabytes per day, support up to 100 client devices, and deploy up to 10 different mobile services at no cost. This means you can build a service for your app, see how well the app does in market, and it will cost you nothing to test whether it will be a success. Only if lots of people start using the mobile service, downloading data and connecting, will you need to pay for it. It's a great way to try before you buy. You can get a free trial subscription at http://aka.ms/azure_trial. You can download the free training kit at http://aka.ms/WATK, stands for Windows Azure Training Kit. And also I blog on all these kinds of topics at http://aka.ms/plankytronics with 2 X's. I hope you enjoy your adventures with the Windows Azure Mobile Services.